Worksheet 15D, also indeterminate beams. For the beams loading zone, determine the support reaction at A, C, and D for this situation, and they give us P is 20 kips and L equal to 18 feet. So each L over 3 is 6 feet, as you can see. So just use your statics knowledge. The roller at A, so we have that AY. Roller at C, we have CY. And D are pins, so we have DY and DX. So from your statics, we have 3 equation, and here 4 unknowns, and again that there is one redundancy, and that make the structure become a statically indeterminate structure, in this case the beam. So we have that 4 unknowns here is AY, CY, D, X, and DY. So with that, we cannot use equilibrium equation immediately, that hopefully to find out all of those 4 unknowns. So from that, we use the compatibility and the deflection that we have. So we can use from here. Let's look at the appendix D, and you can see that the finger not cantilever, no fixed support in that problem. So it's more with the 4, 5, 6, or 7. 7 rule out because no couple apply, and 6 is rule out because no moment, no distributed load apply. So only 4 and 5. So let's look carefully back here. The loss P, as you can see, it not in the midspan of the support, so it more with the finger 5, and you can see there finger 5. But finger 5, as you can see, A, B, and they to have those equation, they have A greater than B, okay, greater than B. Then we have that maximum deflection, and the equation for X less than A. So they have many condition here, and if it X equal A, we have the elastic curve deflection at exactly the point X at A. Then we have Y equal to negative P A square B square over 3 EIL. If it's less than A, so it nothing is greater than A. For the whole beam, as you can see, it the whole beam have L. So with that, we have to very creative to apply this finger 5 in this problem. And now I'm going to show that to you, because fingers only the simply supported beam in this case, so no roller in the middle, so that naturally we remove CY and consider that either external load, right? So let here we can say the first step, because redundant, so we have remove, consider, CY as external load, again like in the previous problem. So when it here, what do I have? The beam, original beam here, and have the roller at A and pin at D, and you can see that, and we have the load P 20 kips going down at B, so that one here 20 kips, and then we have CY. Consider the external load, so you have CY in here, So that one is equivalent to use superposition 20 kips plus CY, right, for that beam. So it equal to simply supported beam, roller and pins with 20 kips going down plus the simply supported beam, roller and pins with the CY going up. CY going up. So how can we, and all is finger 5. So as you can see, go back here, we use finger 5. But for the finger 5, A have to be greater than B. So it means that from the point you start with the X, okay, the X here, A greater than B. If you go from left to right, so A greater than B. Now go back to, yes. For CY, it should be okay, right? If we start that equation and start X from the left, then as you can see, the A in this case A equal to L over 3. So let's write down the L is 18 feet. So that one A is equal to 12 feet. And B equal to 6 feet. So that good. A greater than B. And you can see from the exactly the same. Remember, we have to use exactly the same finger. So from that here, go back to the appendix D. Go back to that equation. So it looked good for the one in the right, for CY with exactly equation. And with that, as you can see, we have the elastic curve is something like that, right? And let's redo it again. Elastic curve, make it more realistic here. And at the C, at point C here, the deflection at point C, that we call that is Y number 2, Y2, okay? Because the next one, we take Y1. And now Y number, the 20 kips, for the simply support, we have the load. In this case, it's 6 feet. And this one is 12 feet. And as you can see, if we start from left to right, X start from left to right, what's the problem? It's not exactly the same finger because the finger is A greater than B. In this case, A only 6 feet and B 12 feet. Not good. So we can manipulate that with the X from the right. And the deflection, it will be like that. It will be like that. And then the point C, let point C here, point C, and point C there. And the deflection at point C, that what we are interested, because that is compatibility, that I call this deflection is Y1. So if they start from the right, so as you can see in that equation, this become A and this become B from right to left, as you can see there, from the finger 5. So bottom line, we can use finger 5, but two different ways. So as you can see here, I make a note here, appendix D, finger 5 from right. And of course this is a appendix D finger 5 and from left. Okay, and what do we have? The compatibility in this case have to have the delta C equal to 0. Compatibility. Require what? YC total equal to Y1 plus Y2 and equal to 0, because that is the roller at C. Roller at C. No deflection at C. So that is Y1, Y2 equals 0. So now we can go back to the appendix and write down the equation. So Y1, what is Y1? In here, equation as you can see, X in this case equal to 6 with the point C and less than A. A is from right, it's 12 feet. So we have that equation in here, PB over 6EI. Okay, so that go down here. What does that mean? We can have Y1 is B over 6EIL X cubed minus L square B square X, and that is the equation for X greater than A, I just write down here. And that for Y2, and for X equal to A, which is exactly at the load, in this case that is the Y number Y2 here, you can see exactly at the load CY. So we can apply that equation there, plus, and it going up, plus P A square B square for 3 EIL. And that one, the first for Y1, and this is for Y2. So as you can see, I let it right out here. That is Y1, and this is Y2. So from that we can Y1, Y2, Y2. So plug in the number, we can have equal to 0. This have to be equal to 0. So plug B, A, all of that in. So we have that is 20 keeps B 6 feet based on equation here, based on the finger here, 6 feet over EI cancel out as you can see. So 6 L the total 18 feet. X, we measure Y1 at about C, so X from the right equal to 6 feet. So you have 6 minus L 18 square B 6 square over X equal to 6 feet. That is the first, and then plus P in this case CY A. Apply the last diagram here. A equal to 12, not 6 anymore, as you can see there. 12 square B 6 square divided by 3 L 18 equal to 0. And from this equation we can be able to find out CY equal to 17.5 keeps going up. One equation, one unknowns. You can see there. So CY now, go back to the statics. We have three equations, three unknown now, so we can be able to solve. So go back to equilibrium equation. So sum up all the force. Sum up all the force in x direction equal to 0. Sum up all the force in x direction equal to 0. And that equal to dx, right? So dx equal to 0. Answer. Sum up all on the you have dy and ay have not figured out. You take moment. Sum up on the moment. Let's take about a to find out dy first. About a equal to 0. So what do you have? You have cy 12, dy 18, positive. So we have cy times 12 plus dy times 18 minus 20 keeps times 6 equal to 0. And cy we have that is 17.5 keeps. So from that we have dy equal to -5 keeps. What does that mean? We have dy equal to 5 keeps. 5 keeps. Yep. 5 keeps going down. Whether it makes sense. Which makes sense because that the load P go in the tend to lift up D. So with that D have to be going down to hold the beam. 5 keeps. And then of course the last one is sum up on the force in y direction equal to 0. We have ay -20 plus cy plus dy, and this 17.5 keeps, and this one -5 keeps. From that we have ay equal to 7.5 keeps, and positive, it means going up, same at our assumed direction on the free body diagram. And with that we answer on the question asked. So as you can see, for this one we still have to use the compatibility and remove one reaction to find out with the deflection and superposition before we can apply the equilibrium equation that we learned in statics to solve for the rest of the problem.